Hello and welcome, Woodrow Wilson friends, family, and students. This is Miss Fields here, and I am joining you for our 14th episode of Math Toolbox. So tonight, we are going to be opening up with our first video on fractions, specifically in comparing the value of fractions with unlike denominators. As with every concept that we've reviewed in our instructional videos, usually there is some type of word problem that accompanies the operation. Doesn't matter if it's multiplication, if it's division of whole numbers, if it's decimals, there's usually going to be a word problem accompanying it, and so I want to get you guys prepared with a word problem related to fractions. So in this word problem, Miss Fields, me, has 4/7 of a chocolate cake. Mrs. Nichols has 2/3 of a chocolate cake. Who has more cake? So in this instance, it's important because, if you want to go to a party and eat tons of cake, you want to know who has more cake. So in this instance, we need to figure out who has more, and we're going to do that by comparing the two fractions. However, you can't just see right off the top who has more. We're going to need to convert these fractions into equivalent fractions with like denominators. As with every other problem, every other operation, every other concept in math, we will organize our work into some sort of foursquare. However, for this foursquare, our labels are a tad different than they were in the past. Top left corner is going to be our comparison box, so these are where the original fractions are going to go. Top right corner is going to be where we find our common denominator. More on that in a second. Next box is our find an equivalent fraction, where we're going to transform our original fractions into an equivalent fraction of like denominators. And last, we're going to state our solution and figure out who has more chocolate cake. First step in our comparison box, we are going to find the denominator. Now, the denominator is the digit that is on the bottom of the fraction, and it tells us how many parts are in the whole. So for this cake, there's 3 parts in the whole. However, there's only 2 parts left. In this cake, there's 7 pieces of cake that represent the whole. However, there's only 4 left. We're going to put the digits that were in the denominator over here. And our next step is we're going to count up by multiples of these numbers until we find a match. Now, it should look something like this. I usually recommend for most find the common denominator boxes to go up at least by 5. However, in this instance with our 3, we had to go up quite a bit more. So what's going on here is you're counting up by multiples of 7. That means you're going to count up by 7, 14, 21, 28, 35. You're going up by 7 each time. And the 3s, same thing, 3, 6, 9, 12, 15, 18, 21, 24, 27. Now, you need to find a match somewhere. I know that 7's not a match. I know that 6 and 14's not a match. I know that 9's not a match. 12's not a match to 21. You need to find the match somewhere in here, and you're going to use that to have your common denominator, which helps you create your equivalent fraction. After some serious investigation, I see that 21 and 21 is our common denominator. We're going to use that information in the next box to help us figure out what the new equivalent fraction is. So what's going on right here is our denominator is 21. Denominator is 21. And we are going to be multiplying the top and the bottom of the original fraction in order to get our new equivalent fraction that we can compare to each other. When they have like denominators, all we have to do is compare the numerator, and you know which fraction's bigger and which fraction's smaller. Now, some of you guys might be wondering, Ms. Fields, how did you get this 7 times 3? How did you know that that was what we needed to multiply the numerator and the denominator of our original fraction by? So let's take a look over here at this 3, at this 7, and you're going to count up. How many groups of 7 does it take to get to 21? Remember, that's our equivalent, that's our common denominator, that we will be using to make our equivalent fraction. So let's count up. 1, 2, 3. 3 groups of 7 equals 21. So we're going to multiply the top and the bottom by 3. Down here, same deal. it takes 7 groups, 1, 2, 3, 4, 5, 6, 7 groups of 21, or of 7 to get to 21. Last step is to multiply the top and the top in order to get our whole equivalent fraction. So 4 times 3 is 12. We get 12 21sts. 2 times 7 is 14. We get 14 21sts. Last step, we need to compare these two fractions in order to determine which one's bigger. Now we know that our denominators are completely equivalent, so we're just going to compare our numerators. Now I know in my mind I would rather have 14 chocolate bars than 12 chocolate bars, so I know that 14 is greater than 12. 14 21st is the greater fraction. However, some 5th graders get lost in the mix when it comes from comparing these equivalent fractions and moving it back to the original fractions. So make sure that you know 14 21sts, the equivalent fraction is 2/3 when you're finally stating your solution. You got to make sure that you're keeping track of which fraction goes with which fraction is equivalent to which fraction. So I know when I'm stating my solution that the person with 2/3 as their amount of cake has more cake than the person with 4/7. That's why it's important to look back at your word problem. So I had 4/7. Miss Nichols had 2/3. Who has more cake? We know that Miss Nichols has more cake than Miss Fields because 2/3 is greater than 4/7. Thank you so much for joining me tonight for a quick episode of Math Toolbox about comparing fractions. This is the first part of our unit on fractions, and it is going to give us a good foundation for how to convert fractions into equivalent fractions and also how to compare different fractions with unlike denominators, which will lead us on to adding and subtracting fractions with unlike denominators. Thank you so much again for joining me tonight. I can't wait to see you tomorrow morning. Have a wonderful night.